All right, in this lecture, we're going to be talking about some of the basics of scripting. When we left off in the last lecture, we showed about the basics of Unity, but now we need to actually add some functionality to our game, and we add our custom functionality through scripting. So I know that some people are afraid of scripting, or they don't like scripting, or they don't think they want to program. But if you want to develop video games, you're going to have to, video games right now are made with computers, so you're going to have to learn how to talk to the computer at some point in time to get what test your ideas to make sure that they work well. So I feel that a good designer has some skills in scripting and can manipulate things and make things work to test them out. So why don't we like scripting is our first question. And I think a lot of that comes down to, it feels like a completely, very rigid foreign language that you have to learn. And one of those things is syntax. Syntax meaning, I can miss a semicolon and the whole thing blows up, or I don't spell something right. And formatting, and where do I put these things, and how do I put them together? The discipline and the attention of detail to putting those things together, making sure everything's spelled correctly, all the dots are in the right places. That takes some time to learn, and it's frustrating at first. And then just putting together logic so that you actually have to design some logic so things are going to work. And so the real boogeyman here is syntax and formatting, I feel. When you misspell something, or don't capitalize something, or miss a semicolon, or don't put your parentheses or brackets in the right place, or just don't know how to call something, don't even know where to get started, that is frustrating to new users. But once you learn these rules and you get comfortable with them, they just become second nature, and you can really start thinking about the logic that you want to use. So there are tools out there that allow us to remove this syntax barrier. Visual scripting tools. If any of you guys have used Unreal, there's a Blueprint that they use that does a good job with this. But we're using Unity right now, so we want to use a Unity visual scripting thing. This should not be used as a crutch. Eventually, you're going to have to use this to learn how to do some text-based scripting, because not every job you go into is going to have one of these tools. But it's a really good way to learn the concepts of scripting without having to struggle through the syntax barriers and just some of the frustrations. It kind of puts the bumpers on even more so than regular scripting does. So we are going to use this tool to learn some of the concepts, and I'll have another video that will show you how to get it and to upload it, but right now I'm just going to show you with what I have. Visual scripting does the same thing as scripting does. It's made with scripting. It does the exact same thing. It just puts a visual interface on it. So when you're using visual scripting, I want you to look at the concepts that you're going to see once you take your programming class. Take this into your programming class, and you should see the concepts lined directly up. And even in this visual scripting, the specific one we're going to be using, you can right-click on any of the nodes that come up, and it will show you the C# for those things. So I want you, when you're using this visual scripting, to think of it as a tool that you can use to learn regular scripting a bit better. So let's talk about the big concepts I want you to learn. Obviously, we're not going super advanced with this. This is a very basic introduction to what we're going to be doing with scripting. But there's three big concepts I want you to understand when we're doing scripting here. The first is events, and events are, in Unity, events are things that Unity does so that we can hook into the logic that we want to do. Unity calls these things, and basically the question we ask when we say what event do we want to go into, it's basically when or where we want something to happen. when do you want this to happen? Do you want it to happen right when the thing becomes alive? Do you want it to happen all the time? Do you want it to happen specifically when it collides with something? The next is variables, and variables are just containers that hold data. So when we're designing something, we kind of define what we're designing with the variables we choose for it. What type of data do we want to hold and manipulate? And we'll talk more about that later. And then functions. And functions are custom pieces of code that someone else wrote or you wrote that perform an action either on the data, on the variables, or they basically do something. So let's start with events. So I'm going to just go over some of the Unity events, the frequently used Unity events. And with these 3 Unity events, you can get a lot done. But Unity, when you create a Unity script, and I'll just show you right now, I'll create a base Unity script. This is where our project left off. I'll make a folder. I don't want to do it in the materials folder. Delete that. I want to do it in the assets folder. Right click, folder, scripts. I made a folder called scripts, and I'll just make a new folder here. I'll make a new C# file. I'll just call it test script. And you can see that this is what you'd see when you would be scripting. You would see these are the events that Unity kind of gives you for free here. It says use this for initialization, and update is called once per frame. But what does that really mean? You're going to see this once you start text scripting, but start happens. Go back to our lecture. Start fires off once when the object starts updating. Like when this comes to life, it happens one time. So you use this when you want to set things up. And you'll see that as we start going through this. Update happens every frame, all the time. It's like a machine gun. So if you're running, you've heard the term 60 frames per second. 60 frames per second is how many frames you're running in 1 second. And so if you want your code to do something all the time, like you said, when do I need to check for input? Well, the answer would be, I guess the user could press the button anytime he wanted to. You'd probably check for that in update because it's always checking for something like that. And then there are a lot of other events, but another one that's used commonly is on collision enter. So on collision enter is when a collider hits another collider. We talked about colliders in the previous lecture, and they're when 2 things interact with each other. Well, Unity, you don't have to. Unity is going to test that for you, and it's going to say, hey, on collision enter, this happened. What do you want to do? And update, it's going to say, I'm firing all the time. What do you want to do? And it's like, I just came to life in start. What do you want to do? And you have to figure out when, using these, you have to figure out where does your code of what you want to do, where does it fit into this? And so the first question you ask is, well, when do I want it to happen? And you pick out of, these aren't the only events, these are just some examples that I'm using here, but you pick the best time at when you would want that to happen with these events. And so they're pretty straightforward. We'll see more of these as we start using this a bit more. The next big concept I want you to learn is variables. And so variables can be a little confusing, but they're pretty straightforward in the fact that they're just containers that hold data. So they're a container that holds data, and that data is a specific type. And so there's different types of data that we can hold, and types of variables we can create. And some of those data types would be like a bool. A bool is a true or false value. If you want somebody to say, like, if this is true or if this is false, you would hold that in a bool type variable. An integer is a whole number, 1, 2, 3, 4, 500. It's a whole number. It's not a partial number. And sometimes you would want that type of value that you want to hold and manipulate. A float is a partial number, 1.5, 0.75, 3.124, 142. I mean, it's pi. If you wanted you would say, when do I use a float or an integer? Well, if you wanted something to have a lot more precision, you would use a float. Something like time has precision, right? Speed probably has precision. So something that you want precision for, you would use a float. Something that you just know is going to be a whole number, like score. You can't have 10.5 points in some games. Maybe if you designed a game where you could. But score would be something like these integers, 1, 2, 3, 4, it counts up. Strings are characters or words. So if you wanted hello, if you wanted to hold the data hello, you would hold that in a string. And you make the variables for the data that you need. And starting out, that's interesting to think about. Well, I have no clue what data I need. But you do know what data you need. If you were making a character and you said, the character needs health. Well, what does health really mean? What does health mean in this world of that we're making? Health is generally a number. If I have 5,000 health, well, that's an integer, right? Or if I can't have 5,000.5 health, then every time I lose health, if I lose one at a time, I would say I need an integer to hold health. Say I was stunned or not stunned. If you had a state, you'd say, are you stunned or are you not stunned? That would be a bool. You'd say, I'm stunned or I'm not stunned. If I said I need speed, and my speed can be, 2 is too slow and 3 is too fast, I need to go 2.5. Well, that would be a float. You would say I need to make a variable called speed that is a float because I want precision to control over this. And say you had something like a name. My name is Justin. You would hold your name in a string variable. So when you're designing your character, and you start off and you say, I don't know what variables I would need for this character to actually code it, just start speaking out. What things do you want? What defines your character? The design is going to tell you what data types and what variables you need to make for your character when you're designing these things. And you'll see how we do this when we use the example in Pong. So these are simple variable types, very simple variable types that you can create, and they kind of make sense. You can get into more complex variable types because you can have a variable of any type of data. Those components, if we remember from last lecture, I had components on my game objects, and I had a collider. You could have a collider type variable. You could have a vector 3 is a variable, but a vector 3, what is a vector 3? Well, it's not one of the simple types. It's a structure that holds 3 simple types in it. So a vector 3 holds an x, y, and a z. 3 floats that represent x, y, and z. So it becomes a little bit more complex, but you can have a variable of anything. Classes like, this is the example, the rigid body. We created a rigid body in here. If you remember, on this cube here, I created this I added this rigid body component type. I could make a variable of type rigid body, and I would be able to access all of the stuff I'd be able to talk to it as a variable type. And if I wanted to change the velocity in that rigid body, I could, because I could make a variable of it, and I can change anything that I need in it. So a variable is just a container that's going to hold a data type that I can then manipulate. And you'll see when we start using these that some of these things can hold nothing. Just the container. You could have an empty container. It's called having a null variable. But it usually happens in these more complex variable types. So yes, variables are just, my representation of what a variable is just a container that holds a data type, and we have to fill out and create and then assign these variables to actually use them in our scripts. So the next point I want to talk about are functions. And functions are custom code that we use to perform an action. And so what would a function be? If you wanted to, say take damage would be a function. Say you had a variable called health, and this variable was just an int that you had in your object, and it was called health, and it was just 100. You could make a function called take damage, and all take damage does is say, give me that health variable, and I'm going to subtract an amount from it, and then I'm going to give you back what the result of that is. And then anytime you wanted to take damage, you could just call that function and say, hey, take some damage. It's like, how much damage? You would pass that in, and then it would return out, here's your remaining health. So you can make custom code that does things, and Unity has a bunch of functions that we use that the C# and Unity's API give you that will allow you to just call functions to do work for you. And there's 3 parts to a function, and this is important because it's going to allow you to read any function if you understand this. The return type is what it spits out, what the function gives you after it's done. It's a data type. All functions have a name, and that name is how we recognize it and we call the function. The parameters are the data it takes in to perform the actions. And so the order it goes in when you would be reading it, and I'll show you this when I pull up the project, it's the return type first, then the name, then the parameters in parentheses. And that's the signature of a function. So you know what it's going to give you, you know what it's called, and you know the information it takes to solve its problem, the parameters. Once you know how to read this, you can read any function. You could find any function because they all follow the same signature. So let's look at an example. Here would be a very simple function to add 2 integers together. And it's kind of a stupid function because the plus sign already does that, but just for the example, you can see that this function that I'd be writing, it returns an int. So if you remember, the return type is what the function gives you after it's done. This returns an int. The name of it is add integers. So the name is just the name. Doesn't really could be called anything. Could be called Justin's integer adder. And it takes in 2 ints, int A and int B. So the type and then the name of the variables that come in here. And then once I put this together, I say all I want you to do is return, and what return does is it just says give me the result of this, and I'm going to that's what I'm going to return. I'm going to return this int. And so this would be a very simple function. Returns an int called int add integers, takes in 2 ints, adds them together, spits it back out here. And that's the return type. And this would be what the C# looks like, but I'm going to load up Diagram, the visual scripting program we're going to be using, and I'm going to show you how this works in that space. And so in the next video, I'm going to show you, we're going to download Diagram, and I'm going to show you how all these things work in a visual scripting program so we don't get too bogged down with the syntax and stuff. So that'll be in the next video.